In this video, we're going to learn another way of solving equations that have squares. So we're going to be using square roots. So anytime you have an x or a variable being squared and it's alone, we can just take the square root of both sides. But when you take the square root, you must remember a positive and negative sign, because isn't there a possibility of getting two different answers that equal 36? You can get 6 times 6 to get 36, but you can also tell me that negative 6 times negative 6 is 36. So if that's the case, you need to remember the plus and minus sign. Once you take the square root of something being squared, it's kind of like that square root cancels with the square, and that x just pops right out. Then you can figure out what the square root of 36 is plus and minus 6. So your answer is just positive and negative 6. But remember, you can only take the square root as long as your x squared is alone. So before we take the square root of both sides here, we must add that 64 to both sides. So now we have x squared is equal to 64. Then we can take the square root of both sides, but when you take the square root, you must remember the positive and negative. Luckily, 64 is another perfect square because 8 times 8 is 64. In number 3, again, that x squared is not alone. In order to get the x squared alone, we have to divide both sides by 9. So we get x squared is equal to 4 over 9. Luckily, when you take the square root of both sides here, when your x is positive and negative, square root of 4 over the square root of 9. And both of those are perfect squares, so we can just take the square root of 4 and the square root of 9 to get x equals positive and negative 2/3. Same thing here. We must add that 64 to both sides to get that x squared alone. X squared is still not alone, so we have to divide both sides by 25. There's no reason to simplify the 64 over 25 until after you take that square root. So once we take the square root of both sides, we get x equals the positive and negative square root of 64 over the square root of 25, which is just the positive and negative 8 over 5. We don't always have perfect squares, but that's okay. You still want to take the square root of both sides, and we still have positive and negative. But now we have to figure out if there are any perfect squares inside of 24. So 24 can be separated into maybe the square root of 4 times the square root of 6, because 4 times 6 is 24. Luckily, 4 is a perfect square. So the square root of 24 becomes 2 times the square root of 6. We don't usually write the times. We just write it like 2 square root 6. So your final answer for this problem is positive and negative 2 square root 6. Sometimes x is not the only thing that's being squared. But luckily, x plus 2 is the quantity that's being squared. So when we take the square root of both sides, that square root and the square still cancel out, and that x plus 2 pops out of the perfect square. The square root of 49 is 7. Now we have to subtract 2 from both sides. But it's very difficult to subtract 2 from two different numbers at the same time. So the way we're going to write it is negative 2 plus and minus 7. So that's negative 2 minus 7, but at the same time is negative 2 plus 7. Negative 2 minus 7 is negative 9, and negative 2 plus 7 is positive 5. So we have two answers. The next one, in number 7, we'll see that x minus 1 is the quantity that's being squared. So the idea here is to isolate the square before taking the square root. So in order to isolate it, you want to add the 16 to both sides. So now we have 9 times that square is equal to 16. The square is still not alone. We have to divide both sides by 9. And now the square is alone. So we can take the square root of both sides. So when you take the square root, this one pops right out because the square and the square root essentially cancel. But you have to remember the positive and negative sign. The square root of 16 over 9 is the same thing as the square root of 16, which is 4, divided by the square root of 9, which is 3. Then we have x is equal to, x minus 1, is equal to plus and minus 4 over 3. But you still have to get the x alone by adding 1 to both sides. So x is 1 plus or minus 4 over 3. And I'm just going to say you can leave it like this, but it's not the only way you can write it. You can also say x is equal to 3 plus or minus 4 over 3. So then that can become So that can become x equals 3 minus 4 over 3, and x equals 3 plus 4 over 3. Because that's what plus and minus means. One of them is a minus sign and the other one is a plus sign. So 3 minus 4 is negative 1 over 3. And 3 plus 4 is 7 over 3. So again, we have two answers. So I'm just going to say you should probably leave it in these two forms. I wouldn't take off if you wrote it this way, but it's not totally the end of the problem. Okay, number 8. Again, we want to get the square alone. So we would add 64 to both sides and divide both sides by 81. And again, you don't actually have to do the division right here. You can just let the expression, you could just leave the expression alone. So now when we take the square root of both sides, that perfect square pops right out. And we have the plus and minus. Square root of 64 is 8. The square root of 81 is 9. Then we can add 2 to both sides. So we get x equals 2 plus or minus 8 over 9. And we really don't like to leave it this way. So this really becomes 26. Oops, it's not 26. Sorry about that. 18 plus or minus 8 over 9. So then we have x equals 18 minus 8 over 9, and x equals 18 plus 8 over 9. And the way we get that 18 is just taking that 2 and rewriting it as something over 9. So if you set up that proportion, you can kind of cross multiply here to get that 18. So now we have x is equal to 10 over 9. And x is equal to 26 over 9. We can leave it like that.